And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Traveling up. Roger, roll, Atlantis.
Water towers fly! Yes!
Tango down to nominal.
Fighting downside SC off. Bring in SC off. Off. It's orange!
Orange 25! Oh my god! Oh my god!
Decollage. What is it? Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
If there's methane to be igniting in the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.
Can you believe it? NASAF is live early for this one. Hello everybody and welcome to the launch of the Starlink 10-3 mission here in a very early morning here at Cape Canaveral. My name is Adrian Ball, I'm your host for today, and we have some very special things going on with today's mission. So that's gonna be an interesting one. Buckle up everybody. I think there will be some very exciting facts that you will learn about today's mission. And before I start to talk about all of these facts, I want to introduce everybody that is on with me here today on today's stream, starting with Mr. Alejandro Alcantarilla Romero. Alex, how is it going?
Boy, 22 flights on a Falcon 9 booster. It's going fantastic. Like this is quite record-breaking flight, I guess. But we're saying that every single month, so I guess it's not that record-breaking when they're breaking records every single month. Anyways, that's that's probably a mouthful, but yeah, I'm excited, man. You know, just keep going, keep pushing the all the records.
Absolutely, and as Alex said, this is a record-breaking flight. We have booster B1064 there on 62, sorry, B1062 on the pad here, flying for the 22nd time. Hopefully, not saying it does yet. It will hopefully in 57 minutes, but we will talk about that. Also, we have Carson today on here, pushing the buttons, pulling the levels as yesterday. So welcome back, Carson. And we also have D in the field, who is right now getting more cameras up, so we will hear from D later on today's cast. And we also have Gage in the background, also assisting with some of the cameras here in today's tracking. And with that, Alex, let's talk about today's mission. What's special about this?
Well, it's a Starlink, of course. So a lot of people are always like, it's another Starlink. But you know, first of all, I gotta say it's an early morning Starlink. This is a rarity because you know Starlinks are usually late at night or maybe you know late afternoon or something like that. But today we're having it. You know, it's a little bit past noon for us, Adrian and I. But out there at at the Cape, it's barely past 6 a.m., so it's a very early morning Starlink. Apart from that, today's mission is carrying 23 satellites, which, you know, if you remember from Group 10-1 and 10-2, those two carried 22, which is interesting. It's a bit of a change for these Group 10 missions, but, you know, this is only the third, so there's not a lot of statistic, so to speak, right? It's not something that they have been building up for many missions, like for example Group 6, which had 50 something or 60 something missions. So apart from that, obviously, you know, we have booster B1062 flying for the 22nd time. Should I list the whole list of missions that they have done? Because man, it's quite a long list. So here we go. Let me do it. GPS 3 SVO4, GPS 3 SVO5, Inspiration 4, which is an interesting mission, Starlink 4.5, Axiom 1, Starlink 4.16, and by the way, that turnaround time between Axiom 1 and Starlink 4, Group 4.16, that is the fastest turnaround time for any booster, so this booster is quite a record-breaking already, booster. Nilesat 301, Starlink 4.25, Starlink 426, 436, 5154, OneWeb 17, Arabsat 7B, Starlink 67, Starlink 623, Starlink 630, Starlink 638, Starlink 644, and Starlink 649, and Starlink 659.
That's
That is
crazy.
a lot of
Like
missions.
that's a list.
Yeah,
I mean, it would
21
be
flights
interesting.
already.
It would be interesting to hear how many satellites this single booster has launched. It's gonna be crazy.
I don't have the full list, but it's probably way past 600 or 700.
And that's a
Just based on
single
all the
booster.
Starlink missions. Oh yeah, yeah,
Also,
yeah.
Also, hang on. You know, there was this sunrise shot we saw earlier, and I know the rocket is not like there's nothing happening in the countdown rocket yet. Can we show? Yes, can we show that again? Look at that. That's straight out of like a travel advertisement. That's amazing. So sorry, I just saw that in
No,
the side screen, and I had to
looks
bring that up
great.
again because that's insane. And then we go back to the rocket, and the rocket is like gray.
Yeah, there's a lot of morning fog. That's the difference today as well. That it's an early morning launch, so of course it also means that you have this mist and fogginess from the morning humidity and everything. But yeah, I don't know if we can maybe pull up the trajectory. It's gonna go northeast, just like it's been done for the last few weeks out here from the Cape. If you remember, back in the day, they used to do. Look at that view. That's a nice view as well. But they used to do this sort of southeast trajectory where they did a dog leg around the Bahamas out here from the Cape, and now what they're doing for these missions ever since 8.5 Starlink 8.5, they're doing these northeast trajectories. So they have done 8.5, 10.1, and 10.2 northeast. 10.3 will also be northeast. Later in the week, or maybe early next week, we'll have another launch from the Cape, also from Slick 40. That is also going to be another northeast trajectory, another Starlink launch going to the northeast. But essentially, they're doing this sort of thing where they're just going back to the good old northeast Starlink trajectory. Yeah, I think there's maybe a few more stats that we can hit, but let's hit that later into the stream, so we don't deplete them now, so to speak.
Yeah, absolutely. We have tons of interesting facts about today's
Oh
mission.
yeah.
Again, one of them is the satellite amount. We'll catch on all of that, but we should probably talk about the timeline and why we have not talked about. Oh, the rocket is still doing something, and that's always interesting with Falcon 9 because we go live a bit earlier than SpaceX actually is fueling this rocket, and the actual there we go. There's the countdown. At 38 minutes, which is about 13 minutes from now, the launch director for today's mission will verify go for propellant load, which will then start in roughly 15 minutes, hopefully. And
someone changed it to say best bend.
Oh no. And yeah, then overall we are going all the way down these milestones. We will cover every single milestone, of course, on the way. But there you can see it, 16 minutes and 25 seconds from now, we hope to see some RP1 and liquid oxygen loading on today's Falcon 9. It's not there yet, but we'll get there, hopefully. And again, the window, how long is it today? What's the exact window duration?
It goes all the way to 11 a.m. Eastern, so they could delay for another 4 hours, and yeah, we don't want that to happen though. I don't know if maybe Carson has the weather forecast for today, but it is really good. As you can see on that view, there's not a lot of clouds. It's just some thin clouds up there in the air. There's no lots of winds or anything like it. We're just essentially at a 90% probability of favorable conditions for launch in terms of the weather. So we are definitely not in the same situation that we were at for Falcon Heavy, for example. If you remember from a couple of days ago, where we had only a 30% go at the beginning of our live stream, and then it changed over the course of the live stream, of course. But still, today is 90%. So that is what you see there is the probability of violating weather constraints. So you have to turn around and do 100 minus whatever happens there to give you the probability of favorable conditions. So you see there 10% probability of violating weather constraints, aka 90% chance of favorable weather conditions. So that is a really great chance, and that potentially means that weather is not going to be today a concern for launch.
I feel like we deserve that.
Oh, of
That
course,
we
yeah.
after the last few weeks, where we had like always 70% violation chance, 8%. It was like we basically crossed our fingers for every single launch that it even had a chance, and there were so many slips. So I'm glad we finally get to back to the situation where we have good weather, and no longer, well, this one. So let's see here. There's the rocket from Fleet Cam here.
A little bit
It's
peeking
hard
out.
to see, but believe us, it's there. So let's see here. It's an interesting question here from Westy. Early morning launch, so jellyfish? Question mark. I think we might just be a tad too late, right, Alex?
Yeah, this is late for a jellyfish. It's not really the time for that. If it had been perhaps like an hour and a half earlier, there might have been a chance of jellyfish effect. But I don't think so. The problem with the jellyfish effect, in California they have it a lot easier. When they launch, for example, from Vandenberg, and they launch around around 8:30 or something like that, it is already darkness in places like Los Angeles or like even all the way east to Arizona, for example. So when they launch from there, it's almost still daylight in Vandenberg, and the launch happens and everything. The rocket goes up and it's illuminated, but in those places, it's still darkness, right? So what they see is this jellyfish effect, even though at the launch site, it's still daylight. The problem with the Cape is that the launch happens outwards, so it's not parallel to the coast, or even when they go northeast, it's very hard to actually be parallel because it's it's a bit of a curve relative to, for example, the west coast down there to Baja California. For example, you can actually go pretty much parallel to it while you go into orbit, and that's what they actually do with these Starlink launches from Vandenberg. So if you want a good jellyfish effect from the Cape, you should actually wait for something like at sunset. Even though at sunrise you actually get that backlit sort of situation, but there's a lot more people. For example, in the north of the East Coast, in I can think, for example, North Carolina, Virginia, and all of those places, or even all the way up to New York and things like that. Those places will get much better visibility if the launch is near sunset and it's still daylight at the Cape. But as the as the rocket goes northeast, there in those locations, it is still it's already nighttime, and the rocket is being illuminated by the sun as it heads into orbit. So that could be, for example, a much better jellyfish effect for those people in the ground. But as I said, today it's not jellyfish effect because it's very late after sunrise. So yeah, there's no chance for people to be able to see a jellyfish today.
Yeah, I think we even see some of the fog already being burned off by the sun. You can see that the conditions are less gray now, which usually means there's some sort of burn off from the sun, where you can already see. Like this is already past sunrise. So yeah. Let me thank some people here, starting with Blase, becoming a Pad Red member. Thank you so much for that. And then we have our very own here, Westy, gifting 5 Red Team memberships. Thank you so much, Westy, and thanks for all you do. And we have William Weaver gifting 20 Red Team memberships. Holy cow! Thank you so much for that, and I hope everybody that just got these 20 plus 5, 25 Red Team memberships enjoys the perks. And thanks, of course, the two very generous gifters here. And make sure to enjoy that. And with that, I just checked the SpaceX website. So far, it seems like everything's on track. Because just to like that's a bit of behind the scenes. What we sometimes do is closer to going live, we start to panically refresh the SpaceX website to hope we get info if they like delay into the window or if they're still on track. And right now we are very close to them verifying go for propellant load, and the website is still saying that the liftoff is targeted for 7:14 a.m. Eastern, which is of course the beginning of the window. And there we can see sunrise on Cape 2 camera. Wonderful. So we might.
Life.
The problem is there's like two contradicting effects here. Oh God, Circle of Life. Thank you for that. I will listen to that song later today. We have like the good thing is the fog will reduce. The bad thing is it will get hotter and you'll get like heat distortion. So I'm not sure which I prefer.
I think
Well,
I like this. I think I like this sort of early morning launches precisely because of that. Because it's like, sure, during the countdown you may have that morning mist, that morning fog, but as soon as the sun goes out, it clears it out, and you still don't have that sort of very hot air in between you and the rocket, which gives a lot of atmospheric distortion in the afternoon, especially.
Yeah, for sure. Mark van der Heide used Next Spaceflight, by the way, to calculate the amount of satellites that were launched on this booster. According to Next Spaceflight, it's 574 satellites.
That's a lot of satellites.
That's indeed a lot of satellites.
Yeah.
I mean,
I actually
rocket companies who have not launched that much.
I actually had on my old spreadsheet, I had the sort of like a ranking of like how many satellites each booster has flown. And I remember for a long time, B1058 was the winner every single time because it had flown something like 600 and something satellites. I don't even remember the actual number. When I moved to my current spreadsheet, I started that, but I never went too far. Like I had a lot of more pressing matters, like doing stuff for NSF and everything. So I should probably sit down one day and go through and update a lot of the old stuff, I guess.
Absolutely. And I like the statistics of how many satellites the booster has launched. I think that's a very interesting one. Speaking of interesting, we are right now approaching the moment where we will see the go for propellant load, hopefully. Sometimes SpaceX tweets that out. Sometimes they're not in time for that. We'll see. It's in 4 minutes for now, where they will start, hopefully, to load propellant into this rocket. But yeah, and usually we start to see frost at around like 33, 32 minutes, right? Like that's the rough ballpark where we'll see some frost on the bottom of the rocket.
We always say that it's sort of like a contest between SpaceX posting it on X, or maybe we see it first here on the rocket as it gets frosty. So it's usually a bit of a battle. Lately, it's SpaceX has been winning. That's good because that's what we want. We want more more information from SpaceX. But definitely sometimes it's been a bit of an emptiness there in terms of information. So we have had to rely on the frost appearing on a booster.
Yeah, what's interesting is they have not done their usual like 1 hour until the launch of tweet, right? If I like sometimes they tweet like, hey, 1 hour until the launch of
sometimes
weather remains.
Sometimes.
Yeah.
So sometimes they just don't do that and they just go straight for the propellant load. It's also very early. I suppose that whoever is is posting, they're probably on the Pacific coast. So yeah, it's probably very, very early for them.
True. Let's look at today's hazard zones, because based on the hazard zones, we can, of course, a bit understand the trajectory. You can see here it's going northeast. Alex, what's interesting about these Starlink Group 10 trajectories?
Yeah, well, it's going to the northeast, pretty much like we've seen, for example, on the Starlink Group 8.5. Something similar we should expect next week for the Starlink 8.9. It was supposed to launch on January 30th, but apparently it's been delayed couple of days, at least from the latest marine notices. But yeah, that is essentially where we are. Where we are going to see that rocket heading off. It's going to go to the northeast, like sort of like hugging the east coast of the United States, sort of like that, or going parallel to it. And then the second stage will continue into orbit, and then we'll drop off the satellites. It's going to be a two-burn trajectory, so it's going to be going first to a parking orbit, and then do another burn about 50 minutes into the flight to circularize it. 10 minutes later, the satellites will separate, and then on its own, the second stage will perform a third burn to the orbit, and it'll deorbit in that area, sort of like in between the Indian Ocean and the Pacific Ocean, south of Australia.
Yep, there we go. Quick overview for you of the trajectory here. As that's, of course, I mean, we talk about the booster here because the booster is quite an interesting part of this mission. But of course, the main goal of today's mission is to get the 23 satellites into space. And we should probably talk about this number, Alex, with the 23 satellites, and we had like 22 before, and is it just like, are they slowly going to more 23s, or is it just happen randomly, or what's going on there?
I really don't know. I think there's a good chance that so this is a bit of a long explanation, I guess, but it's very common for me to do that already. When they were launching Group 6 missions, they were able to launch up to 24 satellites on those. And we were told that that was 17,500 kilograms to that orbit. But that orbit was 43 degrees inclination, and today's mission is going to 53-degree inclination. So what does that mean? That means that is the angle sort of between the orbital plane of this orbit that is targeting and the plane of the equator. So if you were to have like a slice right next across, right across the equator on the Earth, you have that slice, and then you get that slice also from the orbit, and so those two have an angle in between. That angle for Group 6 was 43 degrees. For Group 10, it is 53 degrees. So it's a higher angle, it's a higher inclination orbit. So that means the rocket needs more performance to be able to go into that orbit. Why is it that? Where if especially for like general purposes of science, rocket science or whatever, when you see this typical phrase being said that rocket launches need to be close to the equator to take advantage of the Earth rotation. Well, that is only true if you want to launch near the equator. So if you want a very low inclination, that is good. You really need to be low on your latitude to be able to go to a very low inclination orbit. However, if you are low on your latitude and essentially you're spinning fast with the Earth, that Earth rotation, it means that if you want to go to a higher inclination, like say 53-degree inclination versus 43, that means you have to push more against that rotation, because 53-degree inclination does not really give you a lot of oomph. That rotation of the Earth doesn't really give you a lot of oomph. An extreme case you can think of, for example, could be a polar orbit, where you completely eliminate and you have to completely remove that sort of eastwardly velocity from the rotation of the Earth. So what that means is that what I'm trying to get to is that to get to a 53-degree inclination, Falcon 9 needs to expend a lot more fuel, and that means not carrying as much satellites, which is why up until now they've been carrying 22 satellites on board Falcon 9, which means that carrying 23 probably either means that they have been able to find more performance on the rocket, or they have been able to change a little bit the payload capacity of so essentially how much mass they reserve for things like the tension rods that put together the Starlinks, like they keep it together, or the payload adapter at the base, or things like that. Like if they can remove mass from there, then that means they can carry more satellites. Another alternative is that up until now, when they were carrying these 22 satellites to a 53-degree inclination orbit, they were not at Falcon 9's maximum payload performance, and they were just going really nice and smooth with Falcon 9, but now on today's mission they're actually pushing it, and they're going to that limit of potentially 16.8 tons more or less, that we think is 23 stunning V2 mini satellites.
There we go.
It's a long
Absolute.
explanation, but I thought,
I mean,
yeah,
it's complicated factors, right? And we do not always get like the perfect one answer. And to be fair, it could also be a combination of all of this, right? Like it can be a combination of many factors. So we'll have to wait if SpaceX at some point confirms what determines 22 to 23. But so far they have not done that yet. Let's go to D in the field. D, I believe we have you now in comms. What's the situation in Florida? How's the weather? How's the sunrise? How are the conditions changing or not changing closer to launch here?
It is absolutely beautiful out here. The sun is just above the horizon to the right of 39A from my perspective. Above the pad at 40, we have clear blue skies, and it's gorgeous. Weather is 90% go, I believe, with the only concern they were looking at being the cumulus cloud rule. And looking around, there do not seem to be any cumulus clouds anywhere near the pad. So I think we are good in that regard. And, it's a beautiful morning out here.
Absolutely. And we talked a bit earlier about potential jellyfish or not jellyfish. And since you're a photographer, I'm throwing this to you as well. We are probably too late for that, right? With any jellyfish.
Yeah, we're definitely a bit late for any sort of a jellyfish. That really works best after sunset when it continues to get darker. But with it getting lighter, and I mean, the sun is already up and in the sky, so it's going to be too bright for that, but that doesn't mean we won't still have an absolutely gorgeous launch here.
Thank you so much for that. And with that, we are at 33 minutes. So we are officially in let's try to spot some
And-
conversation territory here.
SpaceX has confirmed that propellant load is underway, just by 1 minute. Because if they had done this like 1 minute later, we will have started seeing that frost in the booster.
Yeah, absolutely. And it's like the first thing you usually see is at the bottom of basically just above the bushes and the trees. You can sometimes see like small puffs from the cryogenics being loaded onto Falcon 9, which we expecting basically any second from now. I'm already starting to see things that I think are it, and there we, by the way, see the confirmation. All systems are looking good, and weather is favorable for today's Falcon 9 launch of 23 Starlink satellites from Florida. Propellant load is underway. Confirmation from SpaceX on X. And of course, always good to know that our assumptions about the weather and our assumptions about things are accurate with what the company is tracking. And we see some frost.
Yeah, I started to see frost already in condensation.
You can see just there at the bottom, there's like a small frost ring. And that's,
It's
of
like
course,
this piece of the bush around the rocket that looks like it's pinching it. You know what I mean?
Yep. It's like almost pointing
So
at it,
right
like
above there.
here's the frost.
Right
Alex, do
above
you mind
that's where it is.
do you mind giving us an overview which tank we are seeing here getting frosty?
Yeah, that's the liquid oxygen tank. So at T-minus 35 minutes, the launch auto sequence starts. That is an automated countdown sequence that begins, where a lot of automated systems just start the propellant load sequence, and that sequence starts with loading liquid oxygen and RP1 onto the first stage and RP1 on the second stage. So and this is one of the things that I try to emphasize a lot of times, that normally in other rockets this step is not automated. It's something that somebody has to push a button to keep going, or like there's some sort of automation, but the sequencing of those steps is not automated. Like there needs to be a manual confirmation somewhere else at mission control, launch control, that actually lets the ground systems to proceed into different steps. For Falcon 9 though, the propellant load sequence is completely automated. They can manually abort it though. So if there's any issue that they see and the computers don't see or whatever, they can abort the launch manually as well, all the way to T-minus 10 seconds. So up until that point, they have complete manual abort capabilities there, but you know, the whole sequence is just automated. So this is why when we say, oh, this is going well because this happened at X point in the count, it is because it always happens at that X point in the count. It never changes, or it's very unlikely to change that much, precisely because it is completely automated. So from 35 minutes onward, that is essentially what we see every single time. Every single event happens always at the same time. So T-minus 35 minutes, liquid oxygen and RP1 load on the first stage. The second stage gets loaded with RP1. Then at T-minus 20 minutes and 30 seconds, RP1 load is complete on the second stage. 10 seconds later, the lines for the second stage to essentially get liquid oxygen on board, those get chill down on the Stromberg, and that's when we see the vent, the T-minus 20 minute vent, as the timeline says, the best vent. And then they proceed 4 minutes later into stage 2 liquid oxygen load, and all of the other events, as you can see there, Falcon 9 engine chill, Stromberg retract, all of those events always happen pretty much right on the money at those times. I say right on the money. Sometimes it's like maybe off by a few seconds, but that's not what you see normally with other rockets, where normally, it's not automated. And so some of these events happen a few minutes off. And this is why you get some rockets have these long built-in holds, for example, for Atlas, where they have 30 minutes after fueling has been completed, where they have a lot of time there to be able to check a lot of the systems. Meanwhile, here, they don't have that. They just check the systems before, and they fuel, they load the rocket, and let it go, essentially.
Absolutely. And Falcon 9 is kind of like a victim of its own performance goals there, right? Because thanks to like this load and go procedure, and also to the very tight window, because they want to extract so much performance out of this rocket, they kind of lose stuff like hold capabilities, because there's just like this one single moment where every condition is like lining up and perfectly. And if they miss that in the countdown and they have to like wait, well, it's over, right?
Yeah, that is true. So precisely because they use these super chilled propellants, it is true that once they start loading, now they are committed to the 7:14 a.m. Eastern time for liftoff. So they will not be able to recycle or do another attempt. Potentially, they will not be able to do that. Sometimes, depending on the reasons for the abort and the length of the window, they are able, like they have some capability for recycling, but that recycling involves cutting off the countdown, and then there's also an automated sequence for detanking the rocket, which is awesome. I think that's always really interesting for at least for Falcon 9, that it not only gets loaded automatically, but once an abort has been commanded, either that abort might be manually commanded or automatically commanded. Then there's also another piece of automation there, where the drain back is also done automatically. So they have all of these steps that are all done in sequence and everything as well. But it needs to be drained and then reloaded again. So that takes a bit of time. And so the window needs to be long enough. I haven't seen yet any time where they have been able to retry again and actually launch again. I know that there's been a few times where they have tried to do that, but the problem has been that whenever Falcon 9 aborts, it is for a good reason, right?
Yeah.
Just an example, the other day when the Starlink 10-2 mission aborted at engine ignition, well, they found out that there was a problem with the booster, right? So, and they actually changed the booster before launching that mission again, or trying again to launch that mission. So sometimes when you abort, there's a good reason for that abort, and it means that you really need to stand down and not try again. So it is definitely very hard to do something like that. But fortunately, Falcon 9 is, it doesn't abort that much.
Yeah, I think also the very big confidence in, like, if it's aborting, it's an actual problem, is coming also from their launch cadence. Because
Hmm.
if you launch that much, you get a pretty good understanding of what is an issue and what is not. And remember, there was a time when SpaceX was known as ScrubX because they had so many issues and they had so many
Yeah.
countdown aborts. Like that was a like that. Looking today, it seems absurd that that was a thing back in the day. But there was a time when Falcon 9 had so many issues in the countdown and so often that you like constantly refer to them as like ScrubX. And
Province. Yeah.
yeah, it was a thing. And they turned it around completely and now they are known for basically never scrubbing, which
Yeah.
is a quite a story.
They were also, because I've seen a lot of people already talking about the ULA and Blue Origin stuff. Back in the day when they were known as ScrubX, a lot of the things that ULA used to say, especially to promote themselves, was "we launch on time," and they used to say that. Then NROL 44 happened, and then they stopped saying that. But yeah, back in the day, it was a ScrubX. I started watching live streams of Falcon 9 launches with SES-9, which, boy, that mission delayed so many times. That was essentially the second time they launched the Falcon 9 V1.2 with the cryogenic, with the super chilled propellants, and they had a lot of problems during that countdown and during all of the attempts to get a good propellant temperature and things like that. They even ignited the engines once, and they figured out, well, the propellant temperature is not good for launch, and so they had to recycle and etc. etc. It was quite a mess.
We also had the whole situation with the good old 59-second abort that was quite common back then because that was when the launch computer kicked in, right? Like the rocket takes over flight and it basically Falcon 9 is taking over the countdown, saw something, yeah, no. That was happening like more than once and I love it. But yeah, now they are basically the most reliable and most on-time launch company in the world. So there we go. That's how you turn it around. Here's a question about cadence. Do you think SpaceX would be able to have a higher launch cadence if they use a port further north, like Charleston SC, then barge them back to KC for refurbishment? So basically reducing the drone ship travel, but increasing the rocket travel. I feel like transporting a booster is a bit more of a pain over streets. But that's just me. Maybe, Alex, do you have...
No, I totally agree with that. They could do something like they do at Vandenberg, maybe, where they have a dedicated barge just to transport boosters from Vandenberg, not from Vandenberg, from Long Beach to Vandenberg. So Vandenberg has this dock that was used back in the day for Titan rockets and things like that to drop them off. Then it was later used by ULA for Atlas and Delta, and probably will be used in the future as well for Vulcan. But now it is also being used by SpaceX, where they go to Long Beach to drop off the booster and the fairings, and what they do is they have now a dedicated barge that then transport those. So they put, they remove that from, of course, Loveview and Go Beyond, which is the fairing recovery vessel, and then they put it on that barge, and then they drop them off at that dock, and then it arrives to Vandenberg, and then they can refurbish both fairings and boosters very nicely and easy. So they could, in theory, do something like that, but what happens when the landing is not northeast and it's southeast? Then they do the same at Bahamas, and then they have 2 barges, 2 locations to drop off boosters. Like, it gets more complicated when you get to that point. Or if it's launching straight east, like yesterday mission, for example, not yesterday, the other day, with Falcon Heavy, it went straight east, or even the SES-24 mission just a couple of weeks ago. Not a couple of weeks, it was actually 3 or 4 days ago. Anyways, that mission, for example, it went east as well. There's no land that closed when you go straight east, so it's complicated.
And we are approaching a milestone in this countdown. If you look at the clock in the top left, we are getting ready to hopefully see the T-minus 20-minute vent, which will signify that they are on track for today's mission. Alex, I know I've asked these questions many times, but I will ask it one more time here. What is this vent?
Well, the event that is about to occur here and appear on the rocket, well, not the rocket, on the Stromberg, but we should be just a few seconds. I'm trying to stall a little bit.
There it
There we
is.
go. That's the event. That's the T-minus 20-minute event that kickstarts the chill down of the liquid oxygen line to the second stage on the Stromberg. So the Stromberg has multiple connections. It's actually one single connection, one single quick disconnect, but that quick disconnect has a lot of different umbilicals and different lines. And one of them is the liquid oxygen sort of load and drain pipe, and that needs to be chilled down to those really cold liquid oxygen conditions. So otherwise, you're gonna get really bad interactions there with something that is at the temperatures at Florida versus something so cold that is, I think, 207 degrees below 0 in Celsius. I don't know how much that is. Hang on, I can look it up in Fahrenheit. It will be minus 340 degrees Fahrenheit. It's a really low temperature for the liquid oxygen. So of course they need to chill down that line and prepare that for the liquid oxygen load, which should begin in about 3 minutes from now.
There we go. Final few steps in this countdown. We are already way through it here. And so far, from what we can tell from weather and also from what we see on rocket and everything, well, everything looks good to go for today's mission. And once again, the quick reminder here that today's mission will not only launch 23 Starlink satellites into their 10th shell, but also the fact that this is the first time that SpaceX will fly a booster for the 22nd time, which is quite a number.
Yeah.
So we'll see what happens, and of course the landing will be shortly after launch on, let me quickly say, just read the instructions. There we go. We also got some gorgeous shots here from D, I think. I'm not sure if I already show it here, but look at that.
Yeah, the sun has been just gorgeous this morning. It's passing by a couple clouds, but again, those clouds are still nowhere near the pad itself.
Look at that.
The vent is really just hanging around Slick 40, and the air is very still, so that's really great for our views, not shaking any cameras, anything like that. I think it's going to turn out to be a gorgeous morning for a launch.
It really looks
Absolutely.
great.
I'm looking forward to that track. Also, we are once again in this territory where we have the right amount of clouds potentially for giving the rocket some good context while tracking, while it's not completely like obscured by any rocket, right, D? Like it might be just in that window.
Yeah, so there's a really clear blue patch over the pad, but there is a streak of clouds that I'm looking forward to seeing it pass, and then the clouds get spotty as you really look up. But it's going to be gorgeous, and I look forward to seeing. One of the things that you lose when it is a perfectly clear day is the context of sort of how fast the rocket's moving, but when you have the clouds back there, it really adds to the view.
Absolutely. It's like it's hard to imagine, for example, speed or get context about speed of a rocket if you just have this blue canvas. It's like, okay, it's flying over a blue canvas, got it. But if you see it going through clouds, it just adds, I think, a different layer. So we'll see how it goes from there. We get another question here, Alex, which I find quite interesting. Charlie's asking, how long before the 40th flight of a booster? Is there like a can you basically predict how many new records they set? Is it like once every 2 months, or is there? I don't know.
Well, it kind of depends, right? What if they get rid of this booster, for example, right? Because then if they get rid of these boosters that are in the 20s, then it probably means that we have to wait for one of the other boosters that is in the 10s or something like that to go up to 40, which means it's a bit of a longer wait. But nowadays, they are essentially, they are essentially doing these launches once every month. Like this booster had a 40-day turnaround. It was a little bit longer, but I'm mostly sure that it was because of all the scrubs and everything that we had a couple of weeks ago with that Starlink Group 10-2 mission, which had a 2-week delay. So we could see potentially. So imagine they actually don't scrap this and they don't expend it or anything, or they don't get rid of it. Then that means at our launch per month, we are essentially 18 months away from the 40th launch of this booster, unless they actually go even faster and we get to something like maybe 3 launches in 2 months or something like that, right? Like it could be quite exciting if they get to that point, but you never know, right? So yeah, I think there's a good chance that maybe in the next 2 years we might see that 40th launch. I definitely think that 2024 will see the 25th flight of a booster, and there's some chances that we might see the 30th, but I'm not sure because, again, 1 launch per month. There's only 6 months remaining in 2024. I don't know, but the 30th launch might happen definitely in 2025. Like next year, I really think we might see the 30th flight of a booster. Yeah.
Crazy numbers. Absolutely crazy numbers. If you think about that, the initial goals for Block 5 was like, yeah, flying up to 10 times without major refurbishment, right? That was the line, right? So, and now they are at 22, and actually they like so far we have not seen any signs of them stopping. They're not like constantly losing boosters now in the high fleet. They're just flying them and they're still working. So kind of crazy.
Back in the day, they thought, oh, when we reach 10 flights with a booster, we will need to do like a major overhaul of the booster. It need to like go deep into refurbishment and inspections. And what they found out was, you know what? They actually don't need that. They did do a sort of deep inspection and deep study of 2 boosters, B1049 and B1051, when they hit 10 missions. When they hit 15, they did the same with B1058 and B1060. Those 2 boosters also got a lot of inspections and a lot of studies from that. But once they hit 20, they didn't do anything like that. They actually continued, and they've been pushing, and they haven't done any of that stuff where they pause and they sit and inspect a booster for a long time, for months at a time, and so they are right now, just refurbishing these boosters just as normal.
Interesting. Showing some confidence there in their own program, totally. There's also some questions here about the Merlin engines. There are some switches in the Merlin engines usually, right? From what we know.
Yeah, sometimes they do change the engines on the booster. It's quite interesting because actually they have more flights on the engines than on the booster airframes. So there was I think it was like 6 months ago where SpaceX said on X, on Twitter, that they essentially had flown a Merlin engine for 21 times. Back in that date, the sort of the most flights for a booster was something like 18 or 19 flights, or something along those lines. It was a long time ago. And so we were surprised that they actually had a Merlin engine that had flown more times than the booster itself. So they obviously change Merlin engines out. And I'm mostly sure that even components on the engine itself, like maybe the structure of the engine itself, can be reused multiple times, but maybe the components that go inside of the engine need to be changed out, like pumps or the turbine or something like that. Maybe needs to be, replaced. I don't know, maybe every 5 flights. But hey, if the rest of the engine is good, who cares, right? Like I don't know. Yeah, I personally don't care. It's Falcon 9. That's not like the goal of fully and rapidly reusable launches and everything. That's a Starship. That's a thing for Starship, not
it's
Falcon
like
9. So I'm good with that.
Falcon 9 is more like Falcon 9 right now, of course, is more like, hey, we have these operational goals. how do we even manage to get to them? Because,
Yeah.
of course, Falcon 9 is only the vehicle, pun intended here, to get all of the missions done, and it's quite an impressive manifest that SpaceX is flying lately, and basically they are kind of forced into this amount of reusability. They are forced into turning around boosters fast because otherwise they couldn't fly this manifest. They cannot produce first stages fast enough to like allow them to only fly them 10 times. That wouldn't work.
It's kind of crazy that we were talking about this yesterday on the on the slapping stream, if you will.
Oh god.
With 14.1, but we're talking precisely about how many second stages they are able to produce, because the second stage is expendable for every flight, right? And so that means that every single Falcon 9 launch, it has a new second stage, and that means they need to if they fly once every 3 days or so, then they need to build a lot of second stages, aka one every 3 days or so, which is a lot. It is completely bonkers that they are able to do that. I believe Elon said on the team interview something along the lines of like, we'll try to build more than 200 second stages this year, which is crazy. When they say we're gonna build 1,000 starships every year, and we look at that, and I'm personally skeptical, but also at the same time they're building 200 Falcon 9 second stages. So if they are able to even achieve that on one single place, maybe if you build a few, like maybe 5 of these places, then you get to 1,000 every year. So that's really interesting. It's really, really interesting.
Yeah, absolutely. It's like the manufacturing behind all of this machine, and I'm talking SpaceX as the machine here, is probably the most impressive part of this company. The way they are able to support this launch cadence. And it totally makes sense also with the reusability aspect. Imagine you only get to fly a booster 10 times. That's basically like if you divide it over launches, you kind of need to produce one Merlin engine per launch, right? Because you're like 9-10 flights. So you kind of double your production of Merlins you need to do to support this cadence. If you fly 20 times, you suddenly only have like half a Merlin you kind of use up on the flight. It's all about manufacturing.
If you think about it, though, when they started Hawthorne, all the Falcon 9 production, Falcon 9 at first was expendable, so they had to have a lot of capacity to build a lot of boosters. But once you don't need to build all of those boosters, what do you do with that capacity? Well, it turns out that the second stage, the structure, the tanks, are pretty much made of the same battle sections as the first stage. Sort of like Starship, the second stage, the ship, is approximately made of the same rings and the same structures as the first stage, even though, later down the line, later into the production, things start to change. But the barrel sections, all the rings and everything, that is the same pretty much. So if you think about it, you can use the same tooling that they were using for building a lot of first stages to now build a lot of second stages. So that was quite a help as well, that they are reusing the first stage, because then all of that tooling and floor space can be used then for second stages. And same thing with the Merlins, for example. Once they start reusing a lot of those engines, then whatever Merlin engine that they can make new, they can instead do away with that and just focus on building MVAC engines instead, for example. Even though, one note to say about this, MVAC engines are not Merlin engines, like sea-level Merlin engines that they just slap a bigger and a bigger nozzle to it. It's actually different, but they can reuse a lot of the tooling there as well.
And at this point, we are getting closer and closer to liftoff. So I want to quickly once again check in with the ready for track, getting ready to track this rocket.
Yeah, I'm all ready. Just got another photo of the sky. There's a pretty cool barrier between where the clouds are and the clear area. But yeah, I'm behind my camera, ready to take control and watch this thing fly.
Dan, I wish you the best of luck with tracking, and we will cover here the next 5.5 minutes until liftoff. Looking good so far, looking good. Alex, I know you love this question, so I will throw it to you for a quick and easy answer. How many active boosters does SpaceX have?
Oh, somewhere in between 15 and 17 or something like that. I believe it's like 5 or 6 at Vandenberg and about 9 and 10 from the Cape. It's always in flux, right? So I cannot really remember all the time from memory, but it's always around that number. Every single time that you count them, it's usually around 15, 16 boosters.
Then let's like I think there's one more coming up, right? We saw one more that is getting ready to fly potentially. So yeah, maybe see some booster debut very soon. We'll see. 5 minutes to go here. What are the final milestones here, Alex, in the countdown before they lift off?
Yeah, so we are right now in the final stages of propellant load. So they have already loaded all of the RP1, that kerosene, propellant grade kerosene, for the Falcon 9. It is already loaded on the second and first stages. We are right now in the process, of the countdown where they retract a little bit that Stromback about 1.8 degrees away from the rocket. The top cradle arms at the top of the Stromback open, and then the Stromback retracts a little bit. We also see around this time the end of the liquid oxygen load on the first and second stages. On the first stage, it'll be around T-minus 3 minutes, and on the second stage, around T-minus 2 minutes. And that'll mean that around that time, we're going to see a fully loaded Falcon 9 ready for liftoff. At T-minus 1 minute, the ground computers hand over control of the count to the onboard computers on Falcon 9. The tanks go up in pressure for essentially pressurizing for flight. The FTS is also armed and everything. They do all of those checks. The onboard computers also check all of the systems that they are ready for flight and everything. Hopefully at around that time, around T-minus 45 seconds, the launch director will give the go for launch. So hopefully we get to that launch in just 3 minutes and 24 seconds from now. But we're essentially just in the last few minutes getting ready for launch.
Absolutely 180, 200 seconds to go here on the countdown today. And again, the star of today's show, certainly B1062 here at the bottom of the rocket, which will hopefully return to just read the instructions here and land for a 20-second time. Again, that's one of the goals here. Not the primary. The primary is, of course, to deploy these 23 internet satellites, which recently saw a new edition of a product. I think there's the new Starlink mini dishes that you can now order, where they like basically it's a almost like a iPad size or Kindle size antenna that you can use to also get some internet. Kind of neat product, I have to say. I saw that and was like, that's probably handy for some people that travel a lot. In general, I think it's kind of impressive how far the Starlink portfolio at this point is. It's like they have military satellites, they have, of course, the normal constellation, mini, they have like cruise ships, airplanes. It's crazy. And of course, they have missions that totally look like security missions in the next few days that are also a governmental Starlink satellite, potentially.
It's funny, sometimes they have customer missions and they turn out to be Starlink still.
Yeah, for context, the NRL 186 mission from Vandenberg that will launch on Saturday, well, actually on Friday, is most likely Starshields from the window and the trajectory and everything we know. It's like, it's not a customer mission. It's just Starlink. So,
Falcon
there you
9,
go.
the propellant load has ended. Falcon 9 is now fully loaded with propellants. There you can see that Stromback vent coming back as they drain back all of the remaining liquid oxygen and doing all of the closeouts there on the Stromback as we prepare for liftoff in just 1 minute and 12 seconds from now.
We should hear the call out that Falcon 9 is in startup around the 1 minute mark, so get ready for that. Fully hearing it.
Falcon 9 is in startup.
And once they get the go for launch, then nothing is in the way here of a launch of Starlink 10-3.
And they are go for launch.
Here we go. 30 seconds to go. You will see at the bottom of the rocket maybe some mist from deluge system, and then you will see the plume of the 9 Merlin engines. So get ready for that. And it will all happen in very quick succession. 10 seconds to go. And again, watch at the bottom of the rocket. That's the most interesting part here. And we have ignition. And we have liftoff of Starlink 10-3 with hopefully the 22nd landing of orbital class booster. Let's listen in. Gorgeous audio. I will at this point stab it again, but gorgeous audio here. And also good tracking from D, and also I think Dr. WD40 Wade in the field here, both tracking here. So thank you so much here. But yeah, and again, sound needs to travel. I saw some people being confused why the sound was so late. It takes some time. It needs to reach the microphones first. So there you go. 2 minutes and 15 seconds into flight, as we can see it here going behind the clouds, but still good visibility on it. And
Should be
this
coming up
burn.
very shortly.
Yep, there we go. There's the rocket in space. Watch the Merlin engines go out here in the stage ignition. Well, it didn't show that, sadly. But so here we have Miko. There's the MVAC. And stage separation confirmed. And no stiffenering, I think. Yes? Yes.
Yeah, it seems like it's becoming standard now. Even for, like, the other day we were seeing on that Falcon Heavy, the MVAC didn't have the stiffener ring, so it's just becoming standard now for every mission.
Also, I think the new camera again on the second stage.
Yeah.
Only good to see.
Be having fairing separation. There we go. Looking there at the sun, and now back on the fair. Look at that.
Here we go. Looking the MVAC looks absolutely beautiful in these conditions. Yeah.
It's a really nice to launch. A really nice time to launch a rocket. And there you can see, on both views how different the cameras is, because the blue on the left is different from the blue on the right. That shows you the old version cameras versus the newer version cameras on the second stage. A lot of people always ask us, what is sort of the difference between, because we always mention the sub blocks kind of thing. Sometimes we reference those, essentially like mini upgrades that they do in the middle of those Block 5 boosters. One of those upgrades was precisely that camera On the second stage, it is newer because it's a new second stage. It's always new, so it's the latest technology, so to speak, the latest subblock. But on the first stage, this is a very old first stage, as we were mentioning today. It is flying for a 20-second time. It has already completed that ascent trajectory, and now it is coming back down. It is actually passing by apogee, that you can see that speed going up again as it falls back down. But essentially, it's an older model, right? So the camera's a little bit older. So you can see there's quite a difference there. But gorgeous views, nonetheless.
We also had, I see people wondering about that, and I rewind it. I wonder if that actually was a fly in the fairing. It looked like either it's a very fly-shaped ice, or it was a fly, but on the fairing cameras, there was something that looked very much like a fly when there was fairing deployment.
As long as it's not covering the entire camera, just like they did with SCS-24 the other day, man, that was quite a pity that it was covering the whole thing.
Yep, I saw that as well, Chad. It was either ice or a fly. It was not aliens. I see some people being like, with this aliens. No,
Okay,
it's not.
so we're now going from the mouse on the MVAC to the fly on the fairing.
Yep. Apparently, that's our route
There's
here
a
so
lot-
far.
There's a lot of animals on this second stage. I don't think they can launch to Mars or anything like it, man.
Yeah,
All the
like-
contamination protocols will be going off the lines.
Somebody trying a gotcha here with me because the fly is technically in space. So is it an alien fly? I would say it's an astronaut fly. That's what I got here from you, everybody. That was my jokes. We don't expect landing audio, correct here, Alex? Because it's just read the instructions.
Unless they changed it, but last I know, Jamie said that it's only right now on a shortfall of gravitas, and that is indeed where, the only places that we have been able to hear the landing audio. So just read the instructions, unfortunately. At least as of the last landing on just read the instructions, it didn't have it. I'm kind of doubtful that they really have been able to change that, because these drone ships, they're being turned around too fast to install a microphone, I think. But we'll figure that out soon.
I see a very good pun here. Blazemonger becoming renewing a red their launch director membership and saying the fly is now a flu.
Oh. Anyways,
Sorry.
as you can see there, going back to the launch, you can see there that booster now is streaking through the lower parts of the atmosphere. Is completely clear out there in the Atlantic, as you can see. That
Stage one
is
transonic.
normal.
Oh, hello.
Nice, thanks. It's transonic. Booster is transonic.
Spot the drone ship early. It's always the goal.
But yeah, it's being steering towards the landing site, and now we should be coming up on that landing burn in just a few seconds from now. Watch first for the speed coming down
You can
fast.
see
and
the
then view.
forces on the grid fins. Like, look at these grid fins working.
Stage one landing burn.
There's the landing burn.
The drone ship. Could see it right next to the booster there. And here we go.
Stage one landing leg deployed.
Looking good.
Bam! 20-second landing.
Stage one landing confirmed.
First booster to level up to level 23, now B1062-23 after the 22nd landing. Congratulations, SpaceX. One more record.
It just feels like normal. Like, yeah, it's another booster launching and landing, but it's a record, right? It's like the 22nd launch and landing for a booster. It's a record, and they just do it like nothing happened, essentially. And there you can see
And
MVAC
Seeker
shut
1.
down.
There we go. Now, of course, waiting. Oh, there we go. They're ending. They're ending already. But that's the good view. Pad 40 empty. And we got some very very good milestones here so far. Everything looking good with the mission. 23 satellites more in space right now, and a booster on a drone ship, which is all the good news we want to hear for now. So that's good. We have some. I was told there are potentially some very good replays coming up. So stay tuned for that. I'm just saying there apparently were some very gorgeous shots
Vapor.
at liftoffs. So stay tuned for the replays.
Yeah, I've been told very long vapor cone.
Yep. So
that's gonna be amazing to see. We also have
looking
replays
forward
from
to
other
that.
cameras as well. So yeah.
By the way, what's in the left center here on the shot right now? What's that building in the very left? Is
On the
that your
very
lane?
left.
There's like a
What
building in
building?
the very left and the bottom left of the shot.
Oh, you mean the cylindrical thing there to the left?
Yeah.
That's a new tank that they have added at Slick 40. I don't even know why. I made a comment the other day on X about it, that don't think that because Falcon 9 launches are routine, I don't notice when they add something new to the launch pad. And that was added like essentially in the last month or so, because in late May it was not there, but it was there just a couple of weeks ago, and it's been there for a while. I don't even know what it is it for. There's like a lot of vaporizers near it and everything. So yeah,
maybe some additional capabilities.
Maybe, yeah, that could be the case. I don't really know for what. I will have to investigate and see.
Chris Bergen, Chris Bergen suggesting it's B15.1 ready for Cape slaps.
No, Chris, no. It is.
So if you ever want to have a stream of us sitting there for 6 hours watching a tank get slapped by chopsticks, I might have just the link for you. If you go to our channel, that's the VOD from yesterday. That was one of the weird is the wrong word. Surprising, most unexpected streams I was on ever. That was fun.
Someone says this explains panspermia theory. That's a theory that other organisms have flown from other planets to to Earth and everything. I mean, yeah, I guess if you have a rocket, you can obviously launch a fly or a mouse.
Yeah.
Now with the jokes, I'm gonna tell that to Jamie next time I talk to her. I'm gonna be, now apart from the mouse, you're also carrying a fly to orbit. They have the full zoo in no time. You'll see.
Absolutely. And yeah, when's the pad here expected to launch again, Alex? What's the current reading in your stars in your crystal ball?
Yeah, well, it was supposed to launch again on the 30th, but apparently that launch has been delayed. That is the Starlink Group 8-9 mission. That is now on July 2nd at 2:24 a.m. Eastern, which is an amazing time of the day, I'm sure, for D and everybody out there at the Cape. But that is
Did you just say 3 a.m. Eastern?
2:24 a.m. Eastern. Which will be
wonderful.
24 for you and me. So I'm mostly sure like we're gonna be. Oh wait, I'm not gonna be here. I'm gonna.
Oh, true.
Yeah.
Yeah, I wish
So
the
I'm not gonna be
Americans.
here.
I wish the Americans of the NSF team good luck covering this mission. That's all I'm gonna say about that starting time.
For a 2 a.m. start time, that means that we can go to bed after it. Whereas here we had to get up and be out here nice and early.
That's true.
Just think about this. If it delays into the window, you're going to bed at like 10 a.m. or something like that. Because it opens at 2:24, so that means it probably goes all the way to 6:24 the window, plus an hour or so to get everything together and all of that, plus an hour to come back. That's gonna be going into 8 a.m.
Good thing it's a Starlink and they never delay.
Of course, yeah, it never delays. Well, today we've been lucky that they've hit the opening of the window, but sometimes they do go late.
I'm told there are replays
Ooh, we have replays.
Let's watch some replays.
And these ones will slap but differently than yesterday's replay.
Oh, is that the thing? No, that's real time, right?
That's real time, I think, yeah.
After yesterday, I'm no longer allowed to judge the speed of things on air.
There we go. Yeah, that's
There
definitely
we
real time.
go. Wonderful. Wonderful
It's
shot.
amazing.
You can see how the pad is completely getting smoked. It's not a reslap, chat. It's I see you. No.
Pad is getting slapped. Is that what you're saying?
Yep. Oh, the sound.
Oh, nice. That's really good audio. Wheel.
Baby squeal. You can see the rocket, the camera shaking when the sound is there.
Yeah, a lot of people think that we turn off the audio or something at launch, and it's like, look, that audio takes a little bit of time to reach the camera, and there you can see on the shaking that it really, truly takes time to get to the camera.
Basically, Google speed of sound.
Exactly. And distance, and also on Google Maps, look at the distance between Sleep 40 and the press site, and you'll
Yeah,
see that it takes a few seconds to get there.
There we go. That's
This
the
looks like to be
wider
the hand
shot.
track.
Yeah, I think that's the tracking. Yeah, that's a tracking from D.
There we go. Look at that.
I love how it just like at liftoff, like Falcon 9 just has this streak of fire coming out. Oh, that's wonderful. Really solid. And that's what I mean, right? The clouds just give you context here. Like, the clouds just helps you to understand this object more. That's why I like clouds on launch shots. It's just making them... Oh, look at that.
Wow.
Wow, that vapor cone. It's still going. That was an amazing vapor cone.
It even had like shockwaves.
You see almost how the rocket is drifting. That's crazy. And now going slowly above the clouds. Wonderful. I love the flame of Falcon 9. It's just such a gorgeous rocket in every single way.
It is really good looking.
And I think there's more to come here.
Oh, this is
Oh.
from the...
From the HUD.
Yeah, from the HUD.
I always forget where it's coming from.
Yeah, so just to give a bit of context, the bushes there block the view of the launch pad, but as soon as the rocket lifts off, like just a few
There it
seconds,
is.
you can see there the Falcon 9 just, emerges
Okay.
from behind the bushes.
After I said I always forget where it's coming from, somebody in chat said from the bottom. I'm aware of that. Thanks.
And then you can see that, that pitch that it does when it goes
T.
downrange.
Look at the right. T is moving.
Oh yeah, it's going up. Same thing here with FleetCam. it's somewhere there, but you'll see it better when it lifts off, of course.
Yeah. It's like there's a rocket in this picture, we promise. There it is.
I mean, well,
Right
there's
side.
2 rockets because there's a
True,
booster
there's a
there
rocket boost on.
on the show
Which booster is that?
Hang on, I need to look it up because I don't remember. B10 78. And there you can see 2 boosters, I guess, because one is in flight there, and another one is on the drone ship. That is the cadence that SpaceX is essentially going for now.
And the TE is up again.
There we go.
Pet looks
for
like
another
it
launch.
never launched. The only thing that is different now is that there's no longer a rocket here.
Yeah, that's a really big difference.
True. That's another of the close-up HUD cams, I think. Oh, this is gauge tracking.
Mm.
So this is Gage tracking from his home with one of our deployed assets, which is always a cool thing to say. Like, Gage is literally sitting at home tracking this from there with one of our Cape assets. How cool is that? It's just a very, very neat thing.
You can see that pitch downrange. Really smooth tracking here. Someone was
Absolutely.
asking. Sorry.
Gage has so much experience at this point tracking, and it shows. Like, Gage is probably the best in team in tracking with like robotic assets. Like with
You see all that
things
shaking? That is the sound of the rocket. Oh, you can see there that vapor cone appearing on. Look at that. Now the rocket itself is shaking the camera. And there's the contrail. Someone was asking why is it formed always there? It's essentially because of how fast the rocket is going and the humidity at that altitude. There's like a layer there where it's more prominent, more conducive to produce that. But as you can see, as soon as the rocket clears that area, the contrail is already gone.
Nice. Very good track, Gage. I have no idea which asset this is.
I don't know either.
I will wait for the back channel to tell me.
Someone was asking.
Another
also in the
KSC
chat-
cam.
Oh, okay. There you can see that liftoff. Yeah, someone was asking also in chat whether like what is the highest number for a booster that has flown so far, and it's B1087. That was the other day on that Falcon Heavy launch. The center core was B1087, so that is the highest number for a booster has flown. Psyche, not Psyche, excuse me. That was the other science mission. Europa Clipper, the center core will be B1090. So that's probably going to be the next one that's going to be flying very, very higher up.
Is that already produced, or will we still see that at McGregor?
We'll still have to see that at McGregor, but I'm mostly sure that's going to go through McGregor really soon, in the next few months. That launch is in October, so it needs to go through soon.
Always good to keep out a look at McGregor.
Yeah. Yesterday they have a really interesting Raptor engine ignition, like an engine test of a Raptor on the tripod stand, because now they have been able to refurbish that after the explosion that they had in May, and now they, those are always so gorgeous because you can see the Mac diamonds.
Okay, what's let's see here. We are getting one more replay here ready, so stay tuned for that. D, how was it? Anything special you want to note for this launch?
This was a really nice launch. It kind of felt slow at first. I don't know whether that was just because uh, of the extra satellite or like Falcon Heavy or what, but it felt slow off the pad, and then with the still air, it took a while for the sound to actually reach me, and it was a nice slow ramp up of audio. But then this turned out to be an absolutely gorgeous day. The light hitting the booster as it was passing the clouds, like you said, the clouds really added a lot to the view here this morning.
Yeah, absolutely. It's basically as expected. We very much predicted before the launch what would be great about this launch, and it happened. That's always a good situation to have as a commentator if you don't jinx the opposite. Which
Yeah, and
happens most of the
something
time.
with the temperature, the pressure, the humidity, the vapor cone, we had that for a very long time. So when you all get a chance to see the slow-mo that I captured here, you'll see just how long it lasts. And then there were like multiple vapor cones. They sort of came in waves. It was really cool to see that. And that's just from all the different perfect atmospheric conditions as it reaches transonic speeds.
Yeah, absolutely. Like, I love how we are seeing so many Falcon 9 launches, and we still get to sometimes get these special conditions that just give us a new view that we have never seen before or rarely seen before. So always good to have that. So yeah, let's hope for some more amazing views in the future. And we will show you the slow-mo that Dee captured basically after we have stopped commentary here. So kind of special outro here. And first, I want to thank Dee in the field, of course, for capturing that and also capturing and tracking today's launch and being on commentary. Thank you so much, Dee.
Of course. Thank you for having me.
And I also want to thank Alex here in the studio with me, commentating today's launch and sharing amazing knowledge as always.
It's always a pleasure, and I should remind people that today a really beautiful stat was the 350th launch of a Falcon 9. So 350 launches. If you count only orbital launches, just wait until tomorrow or the day after, I don't remember now, for the NROL 186 mission, which should be the 350th orbital flight of a Falcon 9. But that's the nice stat there, 350 launches already.
And I also want to give a quick shout out to a programming note here of what is about to come here for NSF today, because I mean, there's always very cool guests we have here, but I think today we feature a web broadcast that has a very, very, very cool guest. We will have another recording of Two Funny Astronauts today, and today's guests will be the complete crew from Polaris Dawn. So that's at noon Eastern, so in 4-ish hours from now. So make sure, if you have time later today, to tune in for that. I want to thank Carson and Gage behind the scenes here. Carson, of course, the main operator for today's stream, and Gage for the track and helping with the cameras. Thank you both so much for being on today's stream. I'm Adrian Bile. I was your host. Thanks, everybody, for watching today's stream here in the early morning hours in Florida. And with that... Oh, sorry, Dr. WD-40, of course, with a track during launch. So many people here always. You easily forget somebody. Thank you so much, everybody. And with that, let's watch the slow-mo of Dee and see you all at the next launch.
And here we go.
We have liftoff. Propulsion continues to be nominal.
RS-68 chamber pressure looks good.
Doubling up. Roger, Atlantis.
Water towers fly! Yes! Tango down to nominal.
Flight constellation speed off. Bring in SPD off. Off. It's orange!
Oh my god! Oh my god!
Decollage. Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting in the flare, correct?